Okay, so for second session, we look at two-dimensional thermal analysis. So again, we are repeating the 7 steps. However, when we analyze and we do analysis for two-dimensional scenario, just now what we cover is one-dimensional. Now we look at two-dimensional. So we will use a triangular element to help us to find our answer. So again, recall back the previous triangular solving method. I'll show you on the screen here. So you're having a triangular and label as I, J, and M, again in the anti-clockwise direction. And now it's not a displacement. In chapter 7, again, our displacement will be temperature. So temperature at point I is labeled as T sub I. Temperature at J point is Tj, and so on. And then now we are using the coordinate of xi, yi for point I, and same with others, right? Similar with others. For example, coordinate for j, we use xj. Y coordinate for j, we'll use y sub j. And same with the point M. Okay, so this basically is the same concept that what we learned in the triangular element method. Okay. 2, we select a temperature. Temperature, we have already used the same temperature function, which is T equal to NT. And however, they are standard form already. So we have capital T, which is our global temperature on the left, and then our node function or our shape function. We have, since we're having 3 points, so our N here, we have 3 components, Ni, Nj, and M. And our temperature for point I, we label as Ti, temperature for point J, T sub J, temperature for point M is T sub M. So the standard equation for Ni given by 1 over 2A, A is the area, and recall back what is the equation for area when we analyze for triangular. There's one particular equation for that. Then alpha 1 plus beta I x plus gamma I y. So recall back there's a slides regarding the 9 equation, alpha, beta, gamma, and the area. There's one particular slide for that. We recycle the information. All right. So go back to the previous slides to find the A and alpha, beta, gamma. Okay. So let's see if I have them here. If not, then it's in the chapter 6 already. Okay. Need to go back to chapter 6 slides that we learn about triangular. Okay. Okay, then after we done step 1 and step 2, we go for step number 3, find the temperature gradient, heat flux gradient relationship. So we find the G matrix and the QX matrix. The G given you by B, T, what is B? Given by on this slide, standard already. Okay, B matrix equal to 1 over 2A, beta I, beta J, gamma J, beta M, gamma M. After you calculate the value for beta, gamma, you substitute back here, you'll get the T. Then to calculate the Q flux, you use minus. Again, there's a minus sign for Q flux gradient relationship, minus dG. So if you substitute the G equation here, the heat flux temperature gradient is minus dBT. So just give you some hints there. And since we're dealing with two-dimensional now, so your D will equal to kxx and ky. Okay, kxx and ky. We are now dealing with two-dimensional analysis. So that's why you're seeing kxx and kyy. Step number 4, we will look at the K matrix again. So I think you're familiar that we're having a conduction component. So if you're dealing with two-dimensional analysis and you're using triangular method, your K conduction matrix will become the one that you see on the screen here. Okay, you need to integrate 3 times your the volume dimension. Okay, how to get volume in a 3-dimensional? You have your dy, dx, dx, dy, and dz direction. So you time these 3, you get volume. So meaning the first integration is dx, second integration is dy, third integration is dz. Then you get the answer for conduction in 2-dimensional. But I will simplify everything in one equation here. There's lots of derivation step from here to here, but I will not go that because more of the derivation step is mathematics steps. Okay, for this module is more on application. So at the end, you arrive at this matrix form. So if you want to calculate two-dimensional finite element analysis for heat transfer, you use Kc equal to T thickness area B matrix transpose is a T there, D matrix and B matrix. Then you get the answer for K matrix. So this is a important equation to get the K matrix for conduction. This is represent conduction. Okay, so this one represent conduction. Next one is convection. Okay, first one is conduction. Second one is convection. Again, if you have an element, you have a conduction inside there. Then if you don't have insulation layer, the heat going to expose or release to the surrounding by convection. And there's one more N here. Later, I'll give you the N N equation. Okay. Now we look at the element first. So for the convection component, is a very lengthy calculation again. So if you look at the N matrix there, if you do the calculation for this three multiplication of, sorry, not 3, it's 2. If you pull your H outside, H is a constant value, you multiply these 2 matrix, you will get this quite complex calculation, right? You get not 3 times 3 matrix here, but the multiplication is N matrix times the N matrix at I dimension. Okay, so it's quite headache there lah. Okay, then however, you can simplify them to, you can simplify this convection component here to this one. Okay, so this one, you go through mathematics lengthy calculation. At the end, you arrive at this more simpler structure. You take H, L, the length of that element, length of I minus j times the thickness divided by 6, and then you have 2, 1, 1, 2, and then the rest is 0. Okay, 2, 1, 1, 2, the rest is 0. We'll go through one tutorial question, then you will see the idea. Okay, so again, we are using triangular method. I always the lowest corner of your triangular. I, J, and M. Okay, and this equation, we assume that the losses by convection H is happening at this side, at the side of Ij. Okay, at the side of Ij, that's why the length that you use in this equation is I minus J, this length. This is the L that you use. Okay. So if the convection happen here, then you use the length of here to here lah. And if the convection happen here, then you use the length of this side. Okay, so what is important? This one. Then number 4, you just combine. Number 4, you find the forces again. The forces also given by one equation, which is this one. You have the Q. Once you have the heating element, you need to calculate the forces because of the heat element. Fq equal to this equation. So again, there's a lengthy steps of derivation. At the end, you arrive at this simple equation. So Fq equal to, again, a small f. We look at small element first, and then we combine them. So forces Q, because of heating element given by Q, V is a volume divided by 3,111. So why this one represent what? Okay. So again, this one represent by one corner I. Second one represent by corner J. This one represent by M. Again, we are using triangular shape. So we are having anti-clockwise direction. So I, J, M. Okay. So of course, when it comes to exam or your real scenario, or you use ANSYS to solve, this IJK will given different number. For example, 1, 2, 3, and then another triangular 4, another triangular 5, another triangular 6, another triangular 7, and so on. Okay, so this is how the software solve your problem. But fundamentally, they are using triangular to solve. I, J, K. So the forces that you calculate here also following the sequence. The first one is I point, second one is J point, third one is M. Sorry, not K, M. Okay. So you have this is how you calculate the volume. You take area times the thickness, get volume, and so on. Okay. Then after you solve for the Q and forces, then you look at the flux. If you're given a small Q flux in the question, then you need to use this equation. So again, you use this equation. Lengthy equation, after you calculate, you arrive at this one. So FQ equal to Q star L I minus 1 T divided by 2, 110. So again, the first number here represent point I, second one J, third one is M. Okay, so you have 3 numbers there. So what happened to QI? is that you have Q star Li minus Jt divided by 2, 1. Point J, you have Q, same, 1. However, for M, you don't have value there. Okay, so I think there's one important point in my slides. Okay, our N component, our node function for the third point is 0. Okay, but just accept at this point because this is more on mathematics calculation, right? Okay, so you have 3 equations here, depending on the site that you calculate. So if you are referring to this site, ij, you use the first equation. If you are referring to this site, jm, then you use this one. If you are focusing on another site, this site, you use this one. Okay, so there are 3 equations depending on the forces that you need to find. So the red color one is the forces at the site j, I to j. The middle one, the blue color one, is if you want to find the forces at this site. And the third equation, if you want to find the forces that I highlight with the green color circle here. So this is 3 different equations. Right? Then the third one is the convection forces given you by this equation. So also have 3 equations. Okay. So this is H. You have 3 components there, depending on what site you want to analyze. So as you can see here, the capital Q only have 1. Okay, capital Q, the heating element only have 1 equation because it deal with volume. It deal with volume. So you only have one big matrix that represent 3 value directly, I, J, and M. However, for heat flux, Q, you have 3 sites. For convection forces, you also have 3 sites. Okay, so these are the difference between the forces. And then set 5, you assembly the K matrix, put them into global, solve for the temperature, and then solve for all the remaining unknown, especially on the left-hand side of the equation. Okay, so let's look at this tutorial question, and we use a 2-dimensional analysis now. So if you look at the diagram at the middle of your screen, you're having an element, 2 times 2 meter element, and the temperature on the left-hand side is 100 degrees C. The temperature on the right-hand side reduced to 50 degrees C. Convection value is 20. Okay, convection value is 20 watt over meter Celsius, and you're having a wall at 2 sides there. So let's read the statement. So you have a 2-dimensional body. You need to determine the temperature distribution, temperature mentioned, and they are insulated. Okay, so top and bottom is insulated. H value given, free stream temperature infinity given, coefficient Kxx, Kyy is given. Okay, so Kxx, Kyy given. Since you are seeing this information, straight away is a 2-dimensional analysis. If you're only seeing one kxx means one dimensional. If in the question you see kxx, kyy, then you need to solve for two dimensional, meaning you are using triangular method to solve. Okay. If the question you're only seeing kxx, then you use the first session strategy. All right, thickness assumed to be 1 meter. So how do we solve this question? Okay, thickness, if you draw this one as three-dimensional, thickness is 1 meter. Okay, thickness is 1 meter. Then we solve. So the first one is to do meshing or discretization process. Step 1 is discretization. So we need to break this diagram on the on the right hand side corner into smaller pieces. The shape that we learned just now is triangular. So the most simplest one is break into 2 triangular. In this case, we break into further 4 triangular. So the more triangular that you break will generate more accurate answer. So this tutorial question break into 4. Okay. Okay. So we will do the first step, discretization, means we do the meshing process. We transform the lower corner diagram into a free body diagram that give you 4 elements here. And you label 1, 2, 3, 4 until 5. So for example, element 1 will give you 0, 1, 2, and 5. So by logic, you should already know, identify where is your I point, J point, and K point for element 1. For example, element 1, your I is 0.1. Element 1, your 0.2 is number 2. Element 1, sorry, not K. Your point M is number 5. Okay. What happened? Let's say I pick element 3. Element 3. So element 3, your I point is below J and M. Element 3, your point I is number 5. Your point J for element 3 is number 3. Your element 3 point M is number 4 in the anti-clockwise direction. And I, we always choose the lowest corner of the triangular. Okay, I repeat one more for element 2. For element 2, label I, J, M in anti-clockwise direction. Then look at the diagram that you just draw just now. Put in the node that you draw in the diagram. So just follow 1. Element 2 point J is 5. Element 2 M is number 4. Okay, and so on. So why all this numbering is important? Because when you build your K matrix later on, you need to issue them the ticket number, okay, accordingly. So for example, element 1, okay, element 1, you have 1, 2, and 5. 1, 2, and 5. For example, element K element for number 2. K element for number 2. When you issue ticket, all the number inside here, it will be 1, 5, 4. Because element 2 is I is number 1, J is number 5, M is number 4. So when you build your K matrix element is 1, 5, 4, 1, 5, 4. Then after that, you combine all the K, you get the global matrix. When you combine the global matrix, only you rearrange as 1, 2, 3, 4, 5. Label with a pencil, 1, 2, 3, 4, 5. And you extract number from all the element here. For example, this location is 1, 1, so you go to find 1, 1 matrix there, 1, 1 matrix there, and so on, and combine them into K matrix. Okay, all right, so let's do calculation. So for element 1, again, element 1 is this one, so label as I, J, M. So your first point is 0, 0, because it starts with origin here, X and Y axis here. So point 1 given you by 0, 0, point 2, 2, 0, which is your point J, and your point M is 1, 1. Point J is 1, 1 because it's at the center of this cube. So this location is 1. Project to the right, you get 1. So location of this point is 1, 1. Any questions so far? Everyone good? Okay.
Good, sir.
All right, good. All right, so for element 1, we have 3 coordinate. Actually, it's the same concept like what we learned the triangular method. Now we apply to the heat transfer. As you can see here, I recall the slides for the 9 equation. Alpha, beta, gamma slides. So again, the IJM diagram is given. The locations is given. Again, this slide is for the displacement. As you can see, you have a VM, VJ. This one is displacement. Now you are having the thermal conductivity, so it become a temperature. So you have the UI, you have the UI, VI, and so on. This is for the previous chapter. We are now at the chapter 7 heat transfer. So this is not relevant. The U and V not relevant. You are looking at temperature now. So what is the constant value that you can recycle is the alpha value, beta value, and gamma value. So you are given by all these numbers here. So XJYM means X location at J point. YM means Y location at Y point. Okay, YM here. So you just follow this formula, substitute the value inside here, you get the alpha, beta, gamma value. Okay. So by referring to these slides, this 9 equation, so you can find what is the beta, what is the gamma value. So I will just show you the first one. So beta I equal to Yj minus Ym. So what is your Yj? You go to your I, J, M coordinate. So your Yj is actually 0. What is your Ym? You go to the M point. Ym is 1. So 0 minus 1, you get minus 1, and you repeat the same process for the beta j, beta m, gamma I, j, m. Okay, all this you can cross-check at your revision time. Important you understand how to get all this value. Next, you calculate the area. So area equal to, basically this is a very simple triangular. So you take the base times the height divided by 2. The area of the small element, triangular element here is 1 meter square. So you take the base 2 times 1 divided by 2, you get 1 meter square. So basically here you have your A value, thickness, beta, gamma value. The next one is just substituting the number into the equation. Okay, you have the T, A, beta, and how you calculate. First one, you calculate the conduction matrix, like what you learned in the triangular element in the previous chapter. So you just write the K matrix equation. K equal to T, A area, B transpose, D matrix, and B matrix. So again, recall what is B matrix standard. B matrix equal to 1 over 2A, beta I, gamma I, and so on, like what you see on the screen. D matrix given, standard structure also. D matrix equal to kxx 0, 0, kyy. You substitute inside here. T is 1. Area is 2. Okay, area is 2. Area is 1. Okay. B transpose, written in this way, because your B is 1 over 2A, BI, JM, and so on. So you substitute all this, you do the transpose, you get this form. Plus the 2 there, because 2A, 1 over 2A is half. So you have the 2 on the side here. Then the D matrix, you substitute the value. By using kxx 0, kyy, you get the second matrix. And the B matrix over here, of course, the half is, I move to the front here. Okay, so we have 3 matrices. You can use the online calculator, punch the value, and then, okay, in your answer, you have to give me these 3 matrices here. And then you can straight away give me, after you use the online calculator, you can straight away write your answer in this form. Okay, at the end, on the online calculator, you arrive at 3 times 3 matrix. Important to label your K matrix carefully. In this one, you're looking at element 1, triangular. And the number that you are looking at, you have to label correctly. This is your I point. This is your J point. This is your M point. So I is number 1. J is number 2. M is number 5. So remember to use your pencil right above and the side of the matrix when you do the superimpose later on. So I think you are expert already in the superimpose. So I just need to remind you on how or what are the meaning of the value that you get here. Okay, so far we are still recycling what we learned in the triangular method. Okay, so just need to be careful on the numbering 1, 2, 5, because we are following the sequence of I, J, M sequence. You are looking at element 1 here. You do the same for other 3 elements. You do the same. Actually, it's the same method. I will not repeat the detail because we keep repeating the same concept, right? So element 2, you can check the answer on the slides. So again, this is your I, J, M. If you go back to the diagram, this is your I, J, M. So I is 0, 0. Your point J is 1, 1. Point M is number 4, is 0, 2. Okay, so you get the coordinate. Then you calculate the beta, gamma value. Calculate the area. Okay, beta, gamma. Calculate the area, calculate the thickness. Thickness is given. Again, use back the equation. Kc, conduction, equal to Ta, B transpose, dB. You repeat the same like at element 1. You substitute the value, use the online calculator to find the one that I show on the screen here. Kc number 2, label correctly in your answer. And then remember to remind yourself that actually all this number means something. So when you issue ticketing number, make sure you follow the I, J, M. And why this one is 1? Because you are looking at element 2. This is I. This is J. This is M. You are looking at anti-clockwise direction, and your I always the lowest point. Okay. So far so good, everyone? Good, huh? Okay. You do the same. Element 3, I will go very fast. You do the same. Huh? You get the same. However, what I need to stress here is when you do ticketing number 4, 5, 3, again following the sequence of I, J, M, you look at your screen here. Where is the element 3? Element 3 is here. Anti-clockwise. Or in this case, you pick number 4. Okay lah. So I, J, M. So anyway, if you can pick number 5 as your I if you want, right? But the number will change a little bit lah. Okay. So this sample is using 0.4 as point I. Okay. Just let you know. Repeat for element 4, again the same. Element 4 I, J, M. You can see 2, 3, 5 on the top of the element. Use the same matrix equation. Kc equal to TA, B transpose D and B. However, what need to stress here is that you need to include the convection for element 4. You need to include convection at element 4 because element 4 you're having a convection on these sides. Why? If you look at the original question, you see your element 4 is having a convection this side. So you're having a release of your heat convection here. You don't have heat here because insulated. You don't have heat here, insulated. Element 1 here is the sources of 100 degrees C. So for element 2, you don't have convection, right? So only element 4 released to the left, right hand side. So that's why in your calculation for element 4, you need to include the heat transfer for element 4. So if you substitute the value, HK equal KH equal to H value given, Lij. So you basically you take Ij is 2. Okay. How you know is Ij? You label accordingly. This is I, J, M. So you're looking at this L, Li minus I to J. So it's 2. Thickness given 1. And then the rest is just follow the standard number. So you will get a new H matrix there. Again, mark your matrix with pencil, ticketing number 235, because later you need to do superimpose to get the global matrix for KH. Okay, don't mix with KC and KH. Don't mix them together. Conduction is conduction, convection is convection. So for element 4, you have 2 K matrix. One is for conduction, one is for convection. Okay, just pay attention to that. So separate them. Don't mix them together because they are different mechanism, different heat transfer mechanism. Okay, just now I say don't mix them, right? Just to stress that these are 2 components. There are 2 components for the K matrix, similar matrix for element 4. The one that you're seeing here is the element K matrix there. So if you later you need to calculate for element 4, then you combine conduction and convection value together. Okay, so it's a little bit complicated for element 4. Element 4, you have 2 mechanisms, conduction and convection. So when you need to analyze element 4, especially when it comes to their stiffness matrix K, you combine them together, you get one value. Because this value will help you to find the forces at element 4. Okay. You combine them together, you get one K matrix in one row. So you have 1, 2, 3, 4, 5. Okay, 1, 2, 3, 4, 5. Okay. So this one, it consists of stiffness matrix element 1 plus K matrix number 2 plus K matrix number 3 plus K matrix number 4. And remember, this one is conduction, conduction, conduction. Element 4, you have conduction plus convection. Because here exposed to H. There's a conduction here. There's no H for element 3. So only have conduction, conduction, conduction. No H for element 1. No H for element 2. Okay. So you combine all into one global matrix. Then you solve for the F equal to KT equation. In this case, there's no heating element, so Q equal to 0. No heat flux value given, so 0. You only have convection at site 2, 3 here, so you only have H. So you only need to calculate the FH for this site. What is the equation for FH? Given by H T infinity L T divided by 2, and we're looking at the site that contribute to the convection. H in this case is the side of 2, 3, so you get the length of 2, 3 and 1, 1, 0. You substitute the value, H20, thickness 50, length 2, thickness 1, temperature 50 degrees C, H20, and so on. So forces that generated by convection H is 1000. This one is point I. This is 1000 at point J, 1000 at point M. However, this is element 4. Element 4 point I is number 2. Point J for element 4 is number 3. Point M for element 4 is number 5. What does it mean? It means convection forces at point 3 is 1000 watt. Convection at point 2 is 1000 watt. At point 5, there is no convection, so 0. 0 watt at point 5. So far, everyone good about the value, the meaning of value in the matrix? Okay. So once you get this value, you back to the F equal to KT equation. So this is point 1, point 2, point 3, point 4, and point 5. How you get 1000? I already explained just now. Because point 2, you have the forces of 1000. Point 3, you have a forces of 1000 watt there. Point 5, we know the value of 0 just now. You calculate already. So we only left out F1 and F4. We don't know the forces at these 2 points. K, recycle back. Temperature, rewrite T1 until T5. So in this case, you have 5 unknown. However, T1, you know, T4, you know the value, all right? Because temperature given over here. So you just substitute the value of T1 and T4 as 100 degrees C, because this point is 100 degrees C, this point is 100 degrees C. So you substitute this 100, this 100. Okay, these 2 points, you know the temperature. So once you substitute, you already reduce to 5 unknown, right? This one you don't know, this one you don't know, this one you don't know, F1 you don't know, this one you don't know. You have 5 equation, 5 unknown, you can solve this question. It's a 5 simultaneous equation with 5 unknown. Okay, so again, you do the manipulation of the first number here, the first row that we repeated in the first session. Since you know the temperature one is T1 equal to 100, so you manipulate the matrix into 100 and you manipulate to become 1 T1 0 0 0 0 by using T1 equal to 100 degrees C, and then you what else? And also you manipulate the temperature number 4, this one, by using this value. Okay, this one is this row. Okay, so that's why you are seeing this one become 100 and this one all is 0 except this one is 1 and 0, because this one, if you derive the equation for this row, you get T4 equal 100. You derive this row, you get T1 100. And then you need to check all the numbers one more time in the matrix, whether you already manipulate them already or not. So for example, after you substitute these two, you manipulate the two, you need to check the other you need to check the other, for example here, for example the second matrix here. So once you know the value of T1, right? So you check the second row equation whether it's correct or not based on the first one. After you substitute the value of T1, so you'll get 0. Second row equation matrix here basically doesn't change because your T1, the first one is 0, so basically you don't touch the equation. You check the third row. Third row is this one, 0. It doesn't affect the equation, so skip. Then you come to the last equation. So how you get 500? Why this one suddenly 0 become 500? It's actually a derivation of this equation. You rewrite them into a matrix form. So how you get 500? 0. You rewrite this equation, 0 equal minus 25 T1 plus minus 25 T2 minus 25 T3, this one, plus minus 25 T4 100 plus 100 T5. Okay, So you know the value of T1 and T4, you substitute inside there. You rearrange back into matrix. You know the value of T1. You know this value, 25 times 100, you get 2,500. You know the value of T4. T4 is 100. So 25 times 100, you get 2,500. So 200, 500, 200, 500. You move to the left, you get 5,000. Okay. And then you check also other the value. It should be 5,000. It should be 5,000. No, sorry. It should be 5,000 here, not 500. Okay. Because 25 times T1 is 100, 2,500, 2,500. So when you move these two to the left, it should be 5,000. Okay, there's a typo error in my slides here. Just take note. It's not 500, it's 5,000. Okay, just take note. Okay, so this one becomes 0. This one becomes 0. And you just import back to the matrix. Why you see minus 25 here? Because the equation here is minus 25 T2, and here also minus 25, recycle back 100. So that's why this one becomes 0, this one becomes 0. And again, that typo error in my PowerPoint slides is not 500, it's 5,000. Everyone clear? Clear on the mathematics steps here? Everyone good? All right. There's a typo error. The typo error in my slides, not 500, 5,000, because if I check my equation here, it's not 500, it's 5,000. Okay. 25 times 100 is 2,500. Okay, correct. Yeah, correct. All right. So you run the simulation, you solve for unknown, you will get the temperature. I think temperature is a bit wrong because I think it's not. I think the value, this one is wrong. I think because I use 500 in my calculation. This one should be 5,000. It's not 500, It should be 5,000. Then the value, I think the value is not 84, is something else, because 84 is based on 500 value. So take note, however, the step is same, all right? So okay, so this is how you solve it. You get temperature 1, 2, 3, 4, 5 at that 5 point. What else? Okay, then the rest, there's one more example. I will expect you go and read yourself. It's the same steps, but different scenario, different area of insulator. However, this one come with the Q, with the heat element at the middle of the element. So inside the calculation, you'll see we need to calculate the forces included the Q factor there. Okay, so I expect you go through the PowerPoint slides. The step is quite direct. So if you read and then you don't understand, you can come back to me during the revision week. Okay, so from there you can find the forces of that missing part. Okay, with this I end the lecture.